Scientists have urged the population to tap into high-value crops to create wealth through value addition, but also address the country's challenges like food insecurity and malnutrition. The scientists say crops like bananas can earn the country $953 million annually, and the private sector can tap into the banana subsector to create employment through value addition.
High nutrient-dense foods like the bananas that have vitamin A, as industrial raw materials like cassava with high starch content, as medicines like the improved, like the tissue cultured medicinal plants, and to conserve the environment, and high yielding to make farmers earn more in a smaller piece of land to increase productivity not only per unit area but also productivity in value.
However, this popular crop is affected by a number of diseases and pests that include banana weevil, banana nematodes, black sigatoka, a fungal disease that causes premature drying of leaves, and banana bacterial wilt that causes pre-ripening of the banana fruit. African Agricultural Technology Foundation, AATF, is one of the organizations helping to build the capacity of African countries to tackle agriculture-related challenges using modern biotechnology. The aim is to support mainly smallholder farmers to access appropriate technologies for improved agricultural productivity, benefit from agriculture, and contribute to food security and development. Agricultural scientists at National Agricultural Research Laboratories, Kawanda, have tried to address some of the diseases affecting banana by using modern biotechnology.
Because the conventional breeding approaches uses the genetic material that is available. So if the genetic elements are not available in the existing germplasm, then you don't have what to use because it is crossbreeding. So in that case, we employ biotechnology approaches where we can find such traits in other crops, and then we use biotech approaches to incorporate them in the crop of interest.
The scientists have also tried to address the malnutrition problem through biofortification, and research on provitamin A banana is complete.
From our health survey, which shows us that children below the age of 5, today, 2011, the data from 2011 shows that our children, 38% of those children are vitamin A deficient. Also, 36% of youth between 19 years and 49 years are vitamin A deficient. So it's not just bananas, I think much more beyond the communities that feed on bananas. But we picked on bananas as a staple crop, which could make impact in the larger communities that feed on bananas as a staple food crop. So the contribution of bananas, cooking bananas, enriched with vitamin A, is that 36% of the population, of youth population, will be able to receive enhancement for vitamin A. 38% of children under the age of 5 who are vitamin A deficient, a proportion of that feed on bananas as a staple food crop. They eat bananas every day. So if they eat bananas that have enhanced vitamin A, that's the contribution they get.
So this research started quite a long time ago, around 2005. And it started with the gene discovery process, which took a number of years to select which is the best gene combination to use for this work. And then eventually, after getting some of the candidate genes, we moved into a product development, a proof of concept stage, using succulent as a model crop. So proof of concept was to see that introducing this gene actually increases the levels of provitamin A in the banana fruit. And that also went very well, and we zeroed in on a single gene, which is from another banana called Asupina, that was isolated. That banana is from Papua New Guinea. We have it in our collection here. It accumulates very high levels of provitamin A. So we got that gene, phytoin synthase, and introduced into our cooking bananas. And they have been able to elevate the levels of provitamin A from 2 to 5 micrograms to more than 30 micrograms per gram of dry weight. So with these bananas, you can attain the required levels of provitamin A by consuming just 2 to 3 fingers.
However, in Uganda, there is no regulatory framework for genetically modified crops, and therefore farmers cannot make use of the products.
We have cassava varieties that are resistant to cassava mosaic and cassava brown streak, but they are still in the field trial at Namlonge and Serere, and the scientists are frustrated not to see any mechanism of taking them to the farmers because they have been put into a situation whereby they feel that there is no roadmap, there is no framework.
According to agricultural scientists, improved crops like banana can also play a critical role in national development through agro-industrialization. So
we need to create baby food out of these bananas. We can export high-value nutrients to other countries.
There is still hope that the country will have a regulatory framework on genetically engineered crops, and at the moment, the provitamin A-rich banana is on multi-locational confined fields. Reporting for UBC, I am Juliet Naiga in Serra Natolo.